In this video, we're going to look at factoring by grouping. And first, I want to illustrate something so that maybe what we're going to do makes a little more sense. So first, let's FOIL this. I'm not going to go into foiling. I'm assuming you already know how to do that. So real quickly, 2 times x times 4 times x is 8x squared. 2x times negative 5 is negative 10x, 3 times 4x is 12x, and 3 times negative 5 is negative 15. But let's look at it a little different way. I'm going to put an intermediate step in here so you kind of see a little more about what was going on. What we really have to do is take this first term in this parenthesis times this whole parenthesis, and then we have to do this term times the whole parenthesis. What we're literally doing is 2x times the parenthesis and then 3 times the same parenthesis. And if we distribute, then we get 2 times x times 4 times x, 2x times negative 5, 3 times 4 times x, and 3 times negative 5 is negative 15. So it's the same thing. But the main thing I want you to see here is that this is equal to this. Because factoring by grouping, you're going to end up with an item times a parenthesis and another item times the same parenthesis. And what you can do is make 2 parentheses and put these 2 things, the things that are in front of the parenthesis, in their own parentheses. So here's the 2x, here's the 3 in their own parenthesis, and then just keep one of the duplicates. It's not that this thing really exists twice, it's just being used twice. So you can go from here to here anytime. So now let's factor by grouping. So forget everything above what I just lined off, and suppose you have a worksheet and you're told factor this by grouping. Well, factoring by grouping means to factor a group of 2 and then the second group of 2. You have 4 things and you're going to factor a group of 2 at a time. You have to have 4 terms in order to factor by grouping. The definition of a term is things separated by plus and minus. So you can see this is one term, another term, another term, another term. There's 4 terms. Okay, you can't factor by grouping unless there are 4 terms. And what we're going to do is we're going to take just the first 2 terms here. And we're going to say, what do 8 and 10 have as the greatest common factor? And that's a 2. What do x squared and x have as the greatest common factor? Well, that would be an x. You could think of it as, okay, you've got x times x and x. What do both of these have as the greatest common factor? Well, that would be an x. You could take an x out of x squared, but you couldn't take an x squared out of x. So anytime you're dealing with variables of different powers, your greatest common factor is just going to be the lowest power that is there. In this case, x, or x to the 1. When you factor something out, you always put a parenthesis, and so remember, I'm still just dealing with these first 2 parentheses. I want this times something here to equal this, and this times something here to equal this. So 2x times what equals 8x squared? Well, think about what's 8x squared divided by 2x. Well, 8x squared divided by 2x. Well, 8 divided by 2 is 4, and that cancels into a 1. X over x is just 1, so that doesn't need to be written. That's what cancellation is, and that just leaves an x. Does 2 times x times 4 times x equal 8x squared? Yes, it does. Second term, negative 10x divided by 2x. A negative divided by a positive. 10 divided by 2 is 5. X divided by x is 1, so it's 5 times 1, but obviously we don't need to put that. Now we're going to take our parenthesis and move it over here because I'm just duplicating it because there's still one more number I need to use it to figure out what it is, and that's the number that here I could put here so that this times this equals this and this times this equals this. Well, 12x divided by 4x is 3. And then the final check. Does this number times this number equal this number? Because if it doesn't, something went wrong. It's either not factorable or there's a careless mistake. Now remember the last step. What happens when I have an item times a parenthesis and another item times the same parenthesis? Well, I can make two parentheses, and I can put the two guys in front of the parenthesis in their own parenthesis. And then I just keep one of the duplicate because there were never really two of them anyway. And this is my factorization by grouping of this. And we knew that was going to be the answer because you can look up here and see. Let's do another one. Okay, so I'm going to take the first two terms only and say to myself, what do 12 and 20 have as a common factor? Well, that would be a 4. That's the greatest common factor. You always want the greatest common factor. What's the common factor between r cubed and r squared? Well, I can take an r squared out of r squared and out of r cubed. Now I want this times something here to equal this, and this times something here to equal this. So what's 12r cubed divided by 4r squared? 12r cubed divided by 4r squared, that turns into a 1, that turns into a 1, that turns into a 3, so that just gives us 3r. And then what is 20r squared divided by 4r squared? Well, that just turns into a 1, and so that just is going to be 5. Make a duplicate so we can figure out our last number. So I need something here times this to equal this, and this times this to equal this. Well, what's 15r divided by 3r? That's going to be 5. Final test. Does this number times this number equal this number? And it does. So we know this worked. We make two parentheses, put the 4r squared and the 5 in their own, and we keep one of the duplicates. And we are done. Okay, when I look at this, I look at the first two terms and I think, what factor do they both have in common? Well, only one, but that's not really very desirable. So sometimes it's beneficial to switch the order around. So what I'm going to do is switch a couple of terms here, and you just kind of have to look at it and think what works. You want to group stuff that have at least something the same. Okay, well now this expression is equal to this expression, obviously, because I just switched the order, but nothing's really changed. But now I can pull something common out of both this term and this term. I can take out a 7 and I can take out a y. What is 7xy divided by 7y? So 7xy divided by 7y. That turns into a 1, that turns into 1, just leaves an x. Does 7 times y times x equal 7xy? Yes, it does. Okay, positive divided by a positive, 21 divided by 7, ny divided by n. Well, the y is just turned into a 1. That's just going to leave the n. and then test it. Does 7 times y times 3 times n equal 21 ny? And yes, it does. Make our duplicate. What number has to be here? Well, what's negative x divided by x? Well, that's negative 1. And test it. Does negative 1 times x equal negative x? Yes. Does negative 1 times 3n equal negative 3n? Yes, it does. Make two parentheses, put the 7y and the negative 1 in their own, and then keep one of the duplicate, and we are done. So the thing to remember here is sometimes you need to switch the order of a couple things just to make it work better. Last one. Now, one thing I want you to notice before we look at the last one. So the first one we did here, is there a common factor other than 1 that applies to all 4 of these terms? Well, there's not. What about this one? Is there something I could pull out of all of these expressions, a common factor? No, there's not. Same with this one. There is nothing common to all 4 of these terms. But always check for that, because you can save yourself a lot of headache if you happen to notice that there is something that can be pulled out of all of them. In this case, there is a common factor to all 4 of these terms, and it is 7x. You can verify, but I can pull a 7x out of everything in here. 28 divided by 7, x to the 4 divided by x is x cubed. Does this times this equal this? And it does. And 112x cubed divided by 7x is 16x squared. And always verify quickly, do a fast mental back check. Does this times this equal this? And it does. Negative divided by a positive, 21 divided by 7, x squared divided by x, negative divided by a positive, 84 divided by 7 is 12, x divided by x is just 1. Okay, why was that a good thing to do? Well, would you rather factor this by grouping or just what's in parentheses here by grouping? Well, I would much rather do this because everything's smaller and simpler. So now we're going to proceed with factoring by grouping. This 7x is still going to have to be here, but we're done with it. But now I need to break this up. I need to factor it by grouping. So I'm going to use square brackets here, and I'm going to take these first two terms, just like we always do with factoring by grouping. And I think, what can I pull out of both 4 and 16? Well, I can take out of 4. What can I take out of x cubed and x squared? X squared. Put a parenthesis. What's 4x cubed divided by 4x squared? That's x. And try it. Does 4x squared times x equal 4x cubed? And it does. Okay, what can I take out of positive 16 and positive 4? Well, 16 divided by 4 is 4. X squared divided by x squared is just 1. And so 4x squared times 4 equals 16x squared. Get that parenthesis a little closer. Okay, now I'm going to make my duplicate so I can figure out what number is missing, and that's going to be some number here. Well, what's negative 3x divided by x? It's negative 3. And test it. Does negative 3 times x equal negative 3x? It does. And the final test. Does negative 3 times 4 equal negative 12? And it does. And so we just have one step left. That 7x is still going to be there, but now we're going to make our two parentheses, and this guy and this guy get their own. 4x squared minus 3, and we keep one of the duplicates, and we are done. the best thing to do is go through each of these and try to do them without looking. Get where you can do them without looking, and then check on what I did. And if you get where you can do that, then you will pretty much have a great handle on factoring by grouping.